This UCSD TV program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest programs.
The topic of my talk, I'd like to add a subtitle to it, which is respect to the fact that CARTA seeks to engage the various factors that are part of an evolutionary explanation of human existence on Earth. And the ways in which human beings and climate are wrapped up with one another, I think, is a very interesting and important thing to think about, because environment and the environmental conditions of human evolution set the context for natural selection, for population separation and speciation, and also for extinction, which of course is part of the whole matter of why Homo sapiens is the last biped standing. The traditional idea that has been a focus of the environmental history or of our environmental context of human evolution that has lasted for many, many decades is what we may call the savanna hypothesis of human evolution, that proto-humans 6 million years ago or more were set out onto a savanna grassland, and in this context, in this very basic setting of the stage of human evolution environmentally, came a cascade of all things human, ranging from fundamental traits about how human beings get their food, how we gather the energy to support our hungry brains, and how we evolved the capacity for culture that is very much oriented toward the human transactions with our surroundings today. This is an idea where the environment doesn't really play a major role, because there's just basically a setting of the stage, and what you get this cascade from is one adaptation setting the stage for the emergence of another. But we have learned a lot in the environmental sciences over the past decades. This is an iconic slide, or an iconic data set with regard to the last 10 million years. With 10 million years over here, present over on the left side. And this is based on study of oxygen isotopes, two forms of oxygen 16 and 18, in microorganisms, foraminifera, that live on the bottom of the ocean floor and collected in deep sea cores. And what you can see from this is that there has been an overall trend toward a cooling planet. But a lot of research recently has focused on the nature of the variability. Before 6 million years ago, and this can be traced back to 70 million years ago, these kind of data, you have relatively low-lying variability. And after 6 million years ago, you have a ramping up of the amplitude of fluctuation. Since 3 million years ago, there has been an intensification of glacial fluctuations. And the genus Homo evolved during the strongest fluctuations with the species Homo sapiens, associated with even the most strongest in this timeline of ocean temperature and glacial ice on land. At the same time, we have learned a great deal more in the last decade about tropical African climate. This is one of my favorite records, which is the Sapropel record, whereby the the dark and light bands. The dark bands are organic-rich extrusions from the Nile catchment into the Mediterranean Sea, and the light bands are relatively dry periods. And one can see this back and forth of tropical climate variability, not between glacial ice, not between warm and cold so much, but between wet and dry. And one can see then that these dark and light bands are bundled into periods of stability and instability over time. And of course, the sapropel record related to the Nile catchment basically captures as a record of climate that records from the northeast quadrant of the African continent, and therefore is particularly relevant to things going on in Eastern Africa. And this dark light banding can be captured in spectral reflectance of the dark and light bands, with the light being strong aridity and the dark higher moisture. And this is a record from the last 3 million years ago, and it shows the nature of this variability, but the fact also that it's patterned into these high and low climate variability intervals. And I've just outlined 2 of those examples from this particular data set, this particular sapropel record from the Eastern Mediterranean. Now, we've learned a lot also about the causes of this. The tempo of dry, wet seasonality and dry, wet expression of climate over many, many years is the result of what's called orbital precession, related to the wobble of the Earth's axis of rotation. And that is modulated, it's affected by eccentricity, by the path, the shape of the Earth's orbit around the sun, from more circular to more elliptical or oval-shaped. And during times of high eccentricity, there is a raising of the amplitude of wet-dry variability. And it's been pointed out by quite a number of researchers over the years that the interaction between the 2 timescales of orbital precession and the 2 periods of eccentricity results in a predicted sequence of high and low climate variability. And you can see that represented through time from about this, in this case, plotted from about 1.8 million years ago to the present. And you can see that the time period of greatest interest to us in this particular symposium involved quite a prolonged time period of high climate variability. It also, through mathematical modeling, we can establish the boundaries between a predictive framework and the boundaries between high and low climate variability. And so for the first time, let me show you then for the time period related to this symposium, the alternation of high and low climate variability, with the high defined by periods of high eccentricity. This is the low boundary. The difference between low and high is that amount of eccentricity, which is 1 standard deviation below the average eccentricity for the last 5 million years. These are the intervals of times in thousands of years ago, so 38 to 48,000 years ago is what I've taken this up to. And I've given a slightly broader context back to 638, 640,000 years ago for looking at this particular series of dates for predicted high and low. And we see that these are the durations of these particular time periods of fluctuation, of change from relatively stable climate to unstable climate with high degree of fluctuation between wet and dry for Eastern Africa. And this is, I put this bar here related to the last 400,000 years ago. And one of the things that really pops out is this very prolonged period, 306,000 years in duration predicted for high climate variability, starting about 356,000 years ago and ending about 50,000 years ago. And this encompasses the entire time, nearly the entire time period of what we're talking about here in this symposium, and certainly the entire time period of the development of human innovation as expressed through the Middle Stone Age, which you'll hear about later, the origin of our species, the beginning of the dispersal of Homo sapiens out of Africa. Now, there are relatively few good empirical records other than sapropels and the dust record and blown out into the deep sea that really tells us about what's going on in Africa during this time period. The best one that's continuous, drawn from a core from Lake Malawi, And what has been published so far is a 150,000-year record of dry-wet fluctuation based on a variety of lines of evidence. And this has been called evidence for megadroughts. Time, which is maybe a little hard to see over here, it goes from about 150,000 years ago to the present. And what I've done here is outline the time periods of what the authors have called the megadrought periods. It's a bit of a misnomer in that what it hides is the fact that this time period actually involves a tremendous amount of fluctuation in Lake Malawi level. Lake Malawi today has a depth, a water depth of about 706 meters below the surface. And there are times in the past during these megadroughts when it went to about 125 meters depth. But even within these megadrought periods, such as this prolonged one here, there's considerable fluctuation in moisture and drought. Another excellent synthesis that exists so far for the last 150,000 years ago comes from an article in Journal of Human Evolution by Blom and et al. And it synthesizes data from around the African continent, relatively little from Eastern Africa, but nonetheless, on the basis of this, shows a variety of back and forth between wet and dry from 150,000 years ago to about 30,000 years ago. And two important points here that are in line with this predictive framework of high and low climate variability is that there is stronger variability prior to 50,000 years ago than there is afterwards. Some of these places also have different histories of climate variability. Notice the differences between, for example, South Africa and North Africa. And so what I've done here is to indicate for the last 5 million years, based on this predictive framework, the 8 longest intervals of predicted high climate variability. Here's the one that I just introduced, the one between 50 and 356,000 years ago with a duration of 306,000 years. What occurs is that the entire Middle Stone Age unfolds, at least in Eastern Africa. During that time period, Homo sapiens evolves and the global dispersal begins. But I wondered in these other prolonged high climate variability intervals, what else happens in human evolutionary history? This is what we see in terms of some of the major first and last appearances based on the fossil record right now. So this is likely to change in a number of years as new fossils and archaeological remains are found. But what we have at this stage is that the origin of every major genus in our evolutionary tree, Australopithecus, Homo, and Paranthropus, happen to, at this point, fall in a prolonged high climate variability interval, and that the origin of every single major technological suite of behaviors, the Oldowan, the Acheulean, and the Middle Stone Age, also occur in these time periods of high climate variability. This suggests that one of the hallmark features of our evolutionary history, including the emergence of Homo sapiens and probably related to the extinction of other forms, is this matter of adaptability. And the big question in front of us then is, how does adaptability evolve and emerge over time? By adaptability, I mean this, and this is not just in relation to humans, but any organism, the ability of an organism to endure change in its habitat, where it happens to live at any given point over time and space, to be able to thrive in new places and novel environments, to spread to new habitats, and to respond in new ways to the surroundings. And of course, these are characteristics which some people would say that Homo sapiens, that's really the hallmark of our species in terms of our environmental interactions. Well, where we have been investigating this kind of matter of adaptability and evolutionary change for the most prolonged time in my career, the last 28 years, is in the site, the basin of Olorgesailie. It's in the South Rift of Kenya. You can see this beautiful layering of layers and environmental change over the last 1.2 million years. The most precisely dated sequence of archaeological and fossil fauna and environmental change over the last 1.2 million years. And what we see in very summary form is that between 1.2 and 500,000 years ago, we have Acheulean hand axes, a suite of behaviors that resulted in the repetitive production over such a prolonged period of time of hand axe technology. These large cutting tools, these scales here are centimeter scales, And by this time period, and we're investigating this right now and beginning to write articles on this, work with my colleague Alison Brooks, our colleagues Kay Berensmeyer, Alan Dano are beginning to put together papers on this. But by this time period, we have Middle Stone Age innovations. The Acheulean is no longer around, and you have the beginning of human innovation back this far in time. And that includes smaller, more mobile technologies and the ability to make tools through preparation of the core and new techniques, the ability to repetitively produce these small triangular shaped things, which may be projectile points, and even the accumulation on certain sites of coloring material, black and red coloring material. We also see during this time period a total turnover in the fauna of the southern Kenya Rift, where the large-bodied grazing animals, the animals of the savanna, become extinct, and they're replaced by their modern representatives of hippos and elephants and zebras and baboons and pigs that are far more flexible and adaptable in their ability to change diet, change demographically in their group size, and so on. And so this can be added then, our work in the southern Kenya Rift, to this iconic diagram that was first produced and has been reproduced by many times, but drawing on the work of Sally McBrearty and Alison Brooks in a very important paper from the year 2000. I've added a few things here as well. And what's interesting in this time period from 280,000 years ago to 20,000 years ago, you see these innovations in the Middle Stone Age, so different from what was occurring in the Acheulean and the repetitive behaviors that were occurring. And what's exciting about our work in the South Rift is the possibility of extending some of these things back before 310,000 years ago. What these represent then is the emergence of a smaller, more mobile technology, increasing innovation, wider social networks, possibly including exchange for the first time with distant groups, and the development of complex symbolic activity. These represent ways of cognitively, socially, and technologically buffering the vicissitudes of the surroundings, including the social surroundings. And I think that the context of high climate variability after periods of low climate variability makes sense of this emergence of the ability to buffer behaviorally and culturally. What's going on and what's the future of this, just to conclude? We obtained for the first time from any early human site in Africa a long drill core from Alorgesailie. This was quite an undertaking, but here's the drilling project. And ending just last Friday, was our core sampling party, where we got a chance to split the core. An international group of scientists, 22 scientists, came to begin study of the core. And this is the first public showing of what that core looks like, one small bit of it split. This is quite representative. There are 68 tephra layers of volcanic layers that are amenable to dating through this time period. We think that 216 meters of sediment represents the past 500,000 years in utter detail, including these varve-like deposits, which we think represent seasonal variation in rainfall, and how then we will be able to test how those changes in seasonality are grouped into longer periods of higher and lower climate variability. And so we think that this is the future work that will make this whole project of the climate conditions of the emergence of Homo sapiens an ongoing and important area of study. Thanks very much.
I'm presenting apologies for Sally, who had something come up rather recently and could not be here, but she is represented in the slides. So I'm talking about East Africa, and we deliberately put East Africa in front of South Africa because a lot of though we're now beginning to find out about the longer record of South Africa, it has been a much shorter record in terms of the time span than what we've had in the East for a while. But the question then arises, where exactly is East Africa? If you look at a phytogeographical region map like this one that's recently been published by the American Association of Geographers, you see that actually there is an elevated area of woodlands and savannas with a lot of altitudinal diversity that surrounds and is in the East African Rift Zone that actually has a great deal of similarity in, not that it doesn't have a great many different terrestrial ecosystems within it, but it actually comprises a geographical zone, this olive green area. This is an area that about half of it experiences 2 rainy seasons a year, which makes it a much richer place. And it's also an area where the rainfall zone is wider north to south because of the influence in part of the Indian Ocean monsoon. This area has, and has had for some time, the world's largest terrestrial mammal biomass per hectare or whatever. And theoretically, then, it can support the largest population of predators, among which we have to include the humans for the last couple of million years, anyway. Okay, and then the question is, what is the Middle Stone Age, which is the second part of what I'm going to talk about. And we could define this as a complex of stone tool industries which span the transition from archaic humans to us, but that doesn't tell us much about how you recognize it if you're out walking around. And it's distinctive in its emphasis on hafted points and other tools that are shaped by retouch or pre-shaped on special cores. And this goes along with greater hunting competency. So we also see in the Middle Stone Age, not necessarily from the very beginning, but certainly as it continues, the first signs of symbolic behavior, including personal ornaments, engraved and painted objects and rituals, first signs of regular long-distance exchange, and we also infer a dramatic increase in the complexity of human cognition from the technological and economic strategies that we see developing within the Middle Stone Age. The fishing, the trapping small animals, the making of composite multi-element tools, and the expanded social networks, among other things. Okay, this is a different paper from Blom et al., which I have to confess to being one of the co-authors of, which is why it's showing up so much. This is, rather than showing the places from which we have environmental information, this shows us the archaeological sites in the last of Middle Stone Age affinity in the last 150,000 years. And you can see that if we had drawn this map 20 years ago, there would have been almost nothing that was dated in Eastern Africa, but there would have been some sites in North Africa and a concentration of sites in South Africa. And while it's still dominated by South Africa, the other areas are filling in. When you realize, though, that Africa is more than 3 times the size of the United States, you realize that the middle of it is extremely understudied. But nevertheless, we can begin to say something. So what I want to do is very quickly go over the late Middle Stone Age, since the first modern human fossils attributed to Homo sapiens at about 200,000 years ago, and how it relates to what we'll hear about perhaps from the South African record, but some traits that I don't think show up in the South African record. We do have beads occasionally from East Africa. We have fishing from East Africa, also represented now in the South African record. We have barbed bone points, however, used for fishing in this eastern zone. One of the unusual things about this record, which may not be unusual when they start looking at it more in South Africa, but we do have, from very early on, we have long-distance trade and transport of obsidian in this late time period, and we'll be looking at how far back it goes. We also have possible burial rituals at Herto at 160. We have complex projectile weapons at multiple sites, including geometric shapes. What's distinctive about the East African ones is the very widespread and persistent existence of very small bifacial foliates, which are little leaf-shaped points that resemble North American arrowheads. And we think they actually were, in all likelihood, arrowheads. And this is an example from Aduma in northeast Ethiopia, where I worked in the 1990s. And here we have a progression from the points, the big points that are more than 100,000 years old, to much smaller ones that are perhaps 90 to 80,000 years old above. And all of these points are trimmed at the base for hafting. Almost all of them are obsidian or chert from 4 to 8 different sources, and there are no local sources. So again, we're looking at long distance movement of this material. The small points, we've now agreed among the people who study these things that the small ones are in fact elements of a complex projectile weapon system, which if you think about it, if you're going to invent something like a bow and arrow, we have to accept that you're a modern human. These are some other kinds of points from Mumba in Tanzania, where the Middle Stone Age goes from the bottom of the site to here. And the bottom's about 120,000, and this is about 40,000 right here. And these are in this upper area at perhaps 50,000, these geometric shapes. And right the way through the sequence, but especially in this upper part, this is in northern Tanzania, but the obsidian is coming from Kenya, about 230 kilometers away. And in addition to stone points, we also have bone points. These are from Katanda on the western edge of this eastern zone, on the edge of DR Congo, dated to about 60 to 80,000 years ago and associated with the bones of very gigantic fish that's actually bigger than this one that we were catching. And there's a whole suite of these. There are 3 different sites that we found them at in association with Middle Stone Age artifacts. There's also a possibility that we're looking at mortuary practices in this time range. Tim White has argued that the polish on this child skull from Herto in northeast Ethiopia, dated to about 160,000 years ago, is polished. You can see these areas of polish on the back of the skull here. And it's polished from somebody holding onto it and rubbing it when it was already a skull. And then he argued that this could be part of a kind of mortuary ritual. We very rarely have personal ornaments in East Africa because most of the sites are in open air locations where the organic preservation is very bad. So if they're not making beads out of stone, which we don't think anybody in Africa seems to have done, then we're not going to recover the beads. But where we do have caves, it's interesting that in 3 of the very small number of caves that we have in Africa, we have probable evidence of beads. So this is Nkapune Yamuto in Highland, Kenya, about 50,000 years ago, and we have not only ostrich eggshell beads, but the manufacture of ostrich eggshell beads, along with these very large geometric forms. And also, once these geometric forms come in, they stay. It keeps developing in that direction into the later Stone Age. We don't see a disappearance of these geometric forms and then their reappearance later. Okay, these are ostrich eggshell beads from Mumba, again towards the top of the sequence, but I was able to date one of these by amino acid racemization to 52,000 years ago, and there's recently been a similar date in the very early 40,000s for such a bead. And then these are from Porcupine Cave in Ethiopia, dated to 33 to 60. The argument here is not necessarily that these are man-made or anthropogenic perforations, but that the distribution of these opercula in the complete absence of the rest of the shell suggests human agency in some way. These were collected and described by Zalala Mausafal and colleagues. So what about before Homo sapiens and the early Middle Stone Age? What if we go back, if all of this is characteristic of the last 200,000 years ago, what do we know about the development of this and what happened before this? So before this, what we have evidence from, and I've put in red what we have in Africa that is not, I think, shared with Neanderthals, because when we go back, if we're going back into the past, we're going back to the last common ancestor period that Chris just put up, into the divergence time he just put up. So we have to think, well, if the Middle Stone Age turns out to begin 400,000 years ago, did the Neanderthals leave Africa with the Middle Stone Age? So it turns out that Neanderthals share some of these features, although the interesting thing is they share them quite a lot later. So we have to wonder if there was another out of Africa, if there was an exodus of Homo heidelbergensis out of Africa, and then another exodus with some of these cultural features that we're not catching in the fossils. So what we have are these very sophisticated technologies for making shapes on the core, for taking a core, shaping that core into a particular way, which is very complex and has to be learned. And it does imply sophisticated sequential action and conceptualization. There are a lot of stages in making this that don't seem to be leading towards the final product, unless you can really carefully imitate somebody teaching it to you. And we see these by 500,000 years ago. So that's really the beginning. And it may begin before that in the context of the final Acheulean. Then we see these long-distance procurement networks I've already mentioned. And they're procuring the raw material, not just the finished pieces, which is another difference. We also see these hafted weapons very early on. We also see large quantities of ochre, kilograms of ochre in sites, processed into powder. But what we don't see are ornaments, engravings, or burials with grave goods. So there are some differences with the later period. This is again, this graph that we published in 2000. And just to put some of this here are the fossils. We had an end date of 280,000 years ago, because we thought at the time that was the beginning of the Middle Stone Age. But since then, we ourselves have proved that this was incorrect. We do have these things appearing and disappearing, but what the red lines show is how far back these things now extend to considerably before 280,000 years ago, in many cases. So just a picture of what these prepared cores involve, these allow the production of very thin flakes and points which are shaped on the core. And this technology appears in Africa just before or at the same time as the first specimens of Homo heidelbergensis, about 650,000 years ago. It's a very abstract idea to go from a lump of stone, not to the finished piece, but to the core that is then pre-designed to knock off one of these special flakes. This is a pre-shaped Lavelle point from Olorgesailie, just to show you a real one. Okay, I'm going to also talk about Sally's material. She has sent some slides and text to go with it. This is her work in northern Kenya in the Kaptarin Formation, where a lot of the material is under a tuff dated to 285,000 years ago. This is one of our advantages in East Africa, that we do have a lot of volcanics which can be dated by argon to a very precise degree. And here she has a series of blades which have been published, which are older than 285. And again, this is something that Neanderthals eventually did. But she also has even older blades and cores designed to produce blades from before 500,000 years ago. So the idea of producing these very standardized products on a single core, again, is something very complicated that we don't see earlier. The transition from the Acheulean to the Middle Stone Age involves significant changes in stone toolkits. Eventually, they give up the hand axes and they start producing points. These are parts of composite tools. You need to make a hafting material and system, which could involve binding, could involve glue. It takes a long time to make a haft that you tie them to. You can't just take any old stick or it's not going to fly straight. Spears, and then when you break it, you need to figure out some way to fix it, to repair it. Spears are lighter and more portable than hand axes. And ethnographic analyses suggest that stone-tipped weapons are particularly effective for large mammals. So where do we have some of these points? This is a very early sequence from Gadamota in Ethiopia, where we have some very small points like this one, or this one, that are trimmed at the base for hafting. Here's another one trimmed all the way around. This very flat, invasive working into a perfect symmetrical shape is characteristic of the East African material. We also have these blade-like forms, but very small, with retouched bases as well. We don't quite understand what those are for. And all this is most of this is at least 285,000 years ago. This is Sally's material from the Captarin, and this is under a tuff dated to 230, a series of tuffs, 235 to 284, with more than 2,000 artifacts in situ under this tuff. Some of the artifacts are points like this, and they're made of obsidian. And the obsidian, there are also Lavelle points, which are shaped on the core, which are very thin and symmetrical and straight. And the thing about the obsidian is you can trace where it comes from. And Stanley Ambrose has been involved in a lot of the tracing for both Sally's work and our work at Alorgesailie. And there were little chips that fit back onto these points, and he was able to take the little chips and figure out where the source was. So and in this case, the points, the basic point may have been shaped elsewhere and then refined or finished at the site. Where is the elsewhere? At least a couple of sources, one of which is 130 kilometers away. So again, very long distances that this material is traveling. Okay, at Alorgesailie, and you've heard something about this, this is sites in a locality that we just call B, with a tuff running through it that is dated variously to 305 to 312. And underneath this tuff, we have Lavelle flakes, we have coloring material, we have various kinds of cores. And at this site, BOK2, which is under, as you see, it's under the two tuffs, 305 and 313 here in the wall. All of these little black spots, there are multiple occupations here, and all these little black spots are obsidian. In fact, 55% of the plotted artifacts are obsidian. Here they are. And the lithics include shaped points, Lavelle points, and a whole series of small scrapers. We also have bladelets and biconical bladelet cores. Although these are not the bladelets we have in the late Stone Age, it's nonetheless an emphasis on a very small tool type. And we also have the cores. We have Lavelle cores. We have that point that Rick showed you and that I'm showing you actually fits back onto a Lavelle core. So it isn't just the finished artifacts, it's the whole shebang. So where's it coming from? We have, here's Alorgesailie, a scale of 120 kilometers. We have multiple sources again, and some of them are 40 kilometers, some of them are 60, and there's coming from at least 4 different directions. And that's, we still have 40% of the samples we've looked at that we don't know where the source is. So there's a great diversity in where the material is coming from, and a great deal of the material at the site. So the local raw materials are mostly quartzites and quartz in many of these East African sites, including Aduma, including Alorgesailie, including the Captarin, but the points are preferentially made on very fine-grained materials, which have to be brought from far away. So what's the implication of this far-away transported material? If it's a large home range, you have to know a lot about the environment, and you're going to meet a lot of individuals. You're going to meet people from different groups going to these sources. And you need some way to identify yourself as a friend. So it's not surprising that pigment goes along with this. And it may be that they're trading with these other groups, and that this wide network of relationships provides a way to deal with climate variability, to buffer you against environmental risks. Okay, pigment, this is the last topic. This is from the Captarin, a grindstone with ground fragments of ochre. This is from Alorgesailie with a lump of what we now think is an iron-rich mineral, which has been ground on one side to release a powder. And this is a close-up seeing the grinding striations here from it. And this is from Twin River, Zambia, just so that we get the southern part of this area in here. And here there are many kilos of ochre, more than 6 kilos, in these little pieces that are many of which have been ground. So in conclusion, the sort of take-home message is that there is a gradual transition to us that begins at least 500,000 years ago. And by the time we get to 200,000, 160,000 years ago, and people are beginning, particularly, let's say, by 100,000 years ago, to make complex projectile weapon systems, we're probably, and to conduct mortuary rituals, we probably are very much dealing with us. So thank you.
Good afternoon. I'm going to be talking about the archaeological evidence for complex cognition in the Middle Stone Age of South Africa. What do I mean by complex cognition? In the simplest terms, complex cognition implies the ability to think in the way that we do today. And in defining the Middle Stone Age, in the South African context, I talk about industries that appear with the earliest anatomically modern humans about 300,000 years ago. But as we heard from Alison a little earlier, the Middle Stone Age technology may go back as far as 500,000 years ago. I'm choosing some attributes of complex cognition to talk about today. The use of symbols, planning for remote action, that is when the human actor is some distance from what is going to take place. Thirdly, the practice of delayed gratification, which we can also call response inhibition. And an example of that is when people collect ostrich eggs from a cache and leave some of them behind for the ostrich to hatch out. The ability to multitask, the ability to be flexible in problem solving, understanding transformation, and by that I mean technological transformation. Transformation being the change, for example, in artifacts that are irreversibly changed. So a number of ingredients irreversibly changed. And finally, the use of analogical reasoning. These attributes are likely to have been incremental. They would not have arrived as a package. I've chosen 4 South African sites to give the examples from. 3 of them are in the Cape, Diepkloof, Pinnacle Point, and Blombos. And the 4th one is in KwaZulu-Natal at Sibudu. Blombos is a tiny cave site. It's a coastal site. And it's yielded a number of amazing artifacts that I'll be showing you in a moment. The site was excavated and is being excavated by Chris Henshelwood. The ages here go back to about 100,000 years ago. Pinnacle Point, excavated by Curtis Marion, also a series of coastal sites on a cliff, and the ages here go back to about 160,000 years ago. Diepkloof, inland. This is a rock shelter that was excavated by a French team directed by Texier and Perez, and in collaboration with the South African team directed by John Parkington and Cedric Pochenpoel. And Sibudu, which I've excavated up until 2011, it's now being excavated by Nicholas Connard. This site is perched on a cliff in an evergreen forest about 15 kilometers inland from the sea, and its ages go back to about 77,000 years ago. So the first attribute, the introduction of symbolic thought. One of the things that denote this is the introduction of perforated shells. At Blombos, the age there is about 71,000 years ago, and these are Nassarius shells, many of them. At Sibudu, it's a different species, Afrolitterina and whelk shells, but the age is also 71,000 years ago. The importance of having these perforated shells is that these ornaments, because we believe they are ornaments, are markers of self or group identity, which in turn is an indicator of symbolism. Then both Blombos and Sibudu feature here again with the presence of engraved ochre. The Blombos ones are really famous. They go back about 100,000 years ago. And the best known of these is on the left-hand side, the one with the cross-hatching. At Sibudu, we don't tend to get cross-hatching designs. There, the designs are more fan-like, as you see at the bottom. And the age for the Sibudu ones like that is 77,000 years ago. Deep Kloof rock shelter is well known for its engraved ostrich eggshell. These come from perforated water bottles. On the top right are the perforations that you can see on these pieces of water bottle, and the decorations, the engravings over on the left here. What is most noticeable about the Deep Kloof engravings is that the patterns tend to be these ladder-like designs, and these are repeated on hundreds of pieces of the eggshell, suggesting that we're dealing here with a cultural tradition, not something that was uncommon at all. In the Kalahari today, such ostrich eggshells are used as water bottles. Only a few of them are decorated, and you can see one example there on the right. But the most compelling evidence for complex cognition, I believe, comes from everyday tasks, and so I'm going to be talking mostly about those. The introduction of snaring implies planning for remote action and response inhibition. So the setting of a trap implies that the hunter is going to gain meat without actually seeing the prey that comes to the snare or the trap. And at Sibudu, there is evidence for this, circumstantial evidence, about 71,000 years ago. The fauna there is dominated by blue duiker, a very tiny animal that lives in the forest and would certainly not be sensibly caught either with arrow or with spear. Then the bush pig, which is nocturnal, extremely dangerous to hunt, and so far more likely to have been caught in a pit trap. And then the tiny carnivores, things like mongooses. These are not susceptible to being caught in nets, so we can probably eliminate the possibility of nets, but they are susceptible to being caught in snares. I think one of the most convincing bits of evidence for advanced planning and multitasking comes through the introduction in the Middle Stone Age of compound adhesives. I have to tell you the difference between a compound adhesive and a glue. A glue is a simple product, like a plant gum, whereas a compound adhesive is a combination of ingredients. And the combination of ingredients that I'm talking about here is plant gum, like acacia, together with ochre powder. We found stone artifacts both at Rose Cottage and Sibudu that have these compound adhesives on them. And so in order to try and understand how they were made, I did some experiments to transform a combination of powdered ochre and acacia gum into a compound adhesive. The advanced planning comes with collecting the materials. The acacia gum has to be collected. The ochre powder needs to be ground from pieces that can often need to be collected from great distances. Then the important thing about this is that these natural ingredients differ quite considerably depending on season and where they are collected. And the end result of that is that there is no set recipe like a cake recipe that can be used for making these compound adhesives. Sometimes the acacia gum or the other plant gum is runny and more ochre powder needs to be added. On other occasions, the gum is stiff, and so less ochre powder needs to be added. And so this is all about thinking on your feet while you're making these things, switching attention, changing plan, and indeed multitasking. But the really compelling evidence here for multitasking is once the person has mounted the adhesive onto the shaft and attached the stone tool, and then needs to heat this to dehydrate the adhesive on the tools. And so it's the control of the fire that is ultimately so important. If the fire is too hot, the adhesives will boil and bubble and get air bubbles and be useless, or they may burn if they're too close to the fire. And so without temperature mechanisms, people in the Middle Stone Age would have had to gauge how warm the fire was and how suitable it was for dehydrating without spoiling these tools. So, a good example, in short, of multitasking. Here are compound adhesives at Cebudu by 71,000 years ago, though the examples pictured here are in fact 65,000 years ago. Over on the left is a segment, and I think that you can see there is ochre adhesive attached there, whereas the tool on the right has a different recipe. And that recipe has no ochre in it, but it has black fat. And in the center, you can see the microscopic images that go along with each of these tools. The tool on the left has indeed ochre on it under the microscope, and plant gum up at the top, whereas the tool on the right has fat on the top image, and a series of black fat and white fat if you look carefully at it. The importance of these different recipes for compound adhesive is that the ochre was not necessarily used symbolically when the adhesive was made. If it was used symbolically only within these recipes, we would expect that all the adhesives used at the site would have had ochre in them, so that the hunt was always successful. And that was not the case. There were different recipes. The introduction of compound paint, which we see at Blombos at about 100,000 years ago, follows exactly the same principle. Although it's not compound adhesive, it's a compound paint made of ochre, charcoal, crushed fatty bone, quartz grains, and an unknown liquid. My latest work has involved heat treating of rocks. And the heat treating of rocks in the past, I believe indicates analogical reasoning. Let's have a look at why that would be the case. Some researchers using electrical furnaces have suggested that it's not necessary to bury siliceous rocks underground in order to heat them successfully. However, my experiments with fires, which behave a little bit differently from electrical furnaces, suggest that that's not true. At the top left, I buried silkweed slabs, which I cut into 2 different sizes to imitate the preforms that might have been used for the manufacture of stone tools. Once I'd buried those, I put similar blocks of silkweed on top of the ground, laid the fire on top of that, lit it, and subsequently scraped off a coal bed on which a 3rd set of silkweed blocks were cut. In short, the silkweed blocks that were buried underground preserved perfectly, whereas both the ones in the fire and on the coal bed fractured, as you see in the bottom left picture. One of the experimental fire temperatures is shown on the right. The upper graph shows the temperatures in centigrade of the fire itself. I want you to notice how the temperature ramps up very quickly within the first 5 minutes, is a little bit uneven, and then drops extremely quickly. Whereas the underground temperatures, depicted here, rise slowly, fall slowly, and maintain a very nice curve in the middle. And the temperatures here are between 300 and 400 degrees, exactly the temperature that is needed to transform silkweed. Let me explain why this should happen. When silkweed is heated, it changes its structure. It becomes more fine-grained, and the pore waters in the center evaporate out. If this all happens too quickly, then the silkweed fractures. And that's why the underground temperatures are ideal for making this transformation. And why is it analogical reasoning? Simply because in order to get the underground temperatures that are required, the above ground temperatures need to be controlled very carefully. Here are the archaeological examples that suggest that heat treatment did take place in the Middle Stone Age. At Blombos, at 71,000 years ago, there are some points, A and B, that demonstrate heat treatment. The way that heat treatment can be seen in these artifacts is that when a piece of rock is heated underground or heated at all and then struck, the flakes that have been removed show a gloss, a luster, whereas the exterior of the rock that has not been struck does not show that luster. So both experimentally and archaeologically, we can see that there were pre-forms, pre-shapes laid down to be heated, and that they were subsequently flaked. And Kyle Brown has done experiments with Pinnacle Point rock and has looked at some of the tools from the site to demonstrate that those have been heat treated. In summary, let's have a look at the selected evidence that I've given you for the attributes of complex cognition in the Middle Stone Age. First, symbolism expressed through group or individual identity. Then the long-term planning for remote action and response inhibition through the circumstantial evidence for snaring. Multitasking through the manufacture of compound adhesives and compound paint. This also shows the ability to be flexible in problem solving. Then the concept of transformation is also present in these compound adhesives and paints, but also in the heating of siliceous rocks, in which I also suggest that analogical reasoning, which may be one of the cores of our modern thinking, is also visible. Thank you.